2019, globally, we had about 2.3 million electric vehicles. Can you imagine Tesla, which is the world leader in electric vehicles, is valued at what, $250 billion? 82% of our business is with trucks.
Can you put the vision that we have for 2030 numbers?
So you can see now Ola Electric coming up with the Gigafactory. Ather have already created that initial traction. Automotive sector or the EV sector at large is going to create 100 million jobs.
Hello everyone and welcome to Skillink's first episode on Engineering Leaders. Engineering Leaders is a space where we talk to industry experts about current technical breakthroughs and trends in the industry. For our first episode, we have with us Mr. Anup Srikanthaswamy. He is somebody who's got about 12 years of experience in the automotive industry, out of which the last 7 years has been with Volvo. He's currently the technical leader at Volvo for electromobility. He has also worked in the other domains under automotive, for example, like CAB, vehicle assembly and digital transformation. And as of late, he has also been working in electric vehicles, electric powertrains, as well as fuel cells. More about that in today's talk. So with that, I would like to invite Mr. Anup. So welcome to our show, Mr. Anup. It's wonderful to have you on Engineering Leaders. So to begin with, my first question is, I would like to know a little bit more about your journey in this industry, in the automotive industry. So if you can walk us through that, that would be great.
Thank you, Jennifer, for having me here. I think it's a pleasure to meet you and the team. I'm a graduate mechanical engineer by education, and then I also have specialization in general management from Cornell University, from S.C. Johnson School of Management. So I started off in 2009, working with Toyota in India. I started off in the year 2012 with Volvo, being one of the lead project managers for the Asia Value Truck program that we had. And then eventually took different positions in Volvo. Currently, I'm a technology manager, so I have a global responsibility. I'm leading our efforts in electric vehicles and fuel cells. I belong to a business unit called Quality and Engineering within GTO function. In this years, I took a bit of a break and had an entrepreneurial journey as well. So we were a health tech, insure tech company predominantly. Post that, I moved back to Volvo, so to lead their Industry 4.0 initiatives. I was located in Sweden and then recently moved back due to pandemic, and then I'm now part of this electromobility.
So you've actually worn multiple hats in the last 12 years of your experience, right, in this particular domain. Usually when you look at a professional like yourself, people want to go deeper in the industry, but you've been going broader.
Jennifer, I think if you look at the way things works within automotive industry, you have multiple career paths. You know, people would go for technology areas, so they would like to go deeper into understanding how the technology works and stuff like that. There are other careers where other paths where people would like to take in terms of project management, program management, leading big transformation projects and things like that. I've been there, I've done that. But what I in the last decade or so, what excites me, what inspires me, and what gets me going is to understand the nuances of the business. And that is far more strategic, that is far more impactful. And then I always wanted to upskill myself in the business aspects of it. So I had the opportunity to have great mentors who helped me transition into that. So that's pretty much sums up.
So you would definitely say that even as a senior professional, upskilling, constantly is something that is like a need of the hour that one needs to do, right?
Absolutely.
At any age.
Absolutely. I think the day when you think that you will not be able to learn, that is when you actually that is the end of the life. I think there is enormous amount of learning in all walks of life, and I think and especially in this kind of disruptive world, it's important for you to keep upskilling, open to learning new things.
Adaptability. Basically.
Adaptability and flexibility are the key words here.
Perfect. So you are the technology leader at Volvo for electromobility. So, when you talk about electric vehicles, the first thing people think about is going to be cars and scooters, right? But at Volvo, you guys are more focused on heavy vehicles like construction vehicles, there's trucks, there's buses. Why do you think it's important that Volvo does it? What is the vision behind, focusing in such a niche area? And why do you think this is very important for the future of EV as well?
If you see, largely, 2019, globally, we had about 2.3 million electric vehicles, right? In 2013, it was few thousands. So there is enormous growth and there is enormous potential. Despite this, we are still scratching the surface. So can you imagine Tesla, which is the world leader in electric vehicles, is valued at $250 billion, and they are not even. I mean, we are not even there at 2.5 million vehicles. Imagine the amount of potential that electric vehicle industry brings in. Now, this is the first part. Now, coming to Volvo Group, our focus has been the trucking business. So 82% of our business is with trucks. I would say, in order for us to have our goods delivered to your doorsteps, when you order with Amazon, so you have a hassle-free, doorstep delivery and these kind of things. So the entire mobility leg is enabled by the trucking industry at different stages, and this is a huge societal impact that we are creating.
Yeah, that completely makes sense. It's a wonderful way of seeing also when you're talking about transportation by heavy trucks, giving you more business as well in one way, yeah?
Right.
That's perfect. So that's quite interesting. But as you know, for India's 2030 goal to go completely electric vehicle, there's a lot that needs to be done. So can you put the vision that we have for 2030 in numbers?
So if I put it into numbers, so we can categorize this into various vehicle segments. The first is two-wheeler and three-wheelers, which is huge. So I think India is predominantly a two-wheeler and three-wheeler market. 80% of our current IC engines are sold for to two-wheelers and three-wheelers. So that means that accounts to 80% of the market. Then comes the passenger vehicle, and then comes the commercial vehicles. So in commercial vehicles, you talk about buses and trucks. Trucks, you can further classify into heavy duty, medium duty, and light duty transportation. But if you see largely, what I personally feel is that I think two-wheeler and three-wheeler are the ones that are immediately going to create that momentum. So you can see now Ola Electric coming up with the Gigafactory, and I think Ather have already created that initial traction that was needed. By creating this initial momentum with two-wheelers and three-wheelers, so we have our supplier ecosystem getting ready for this electric revolution in India. Because on the supply side, it is extremely important to have simultaneous engineering and collaboration with suppliers. So if you look at Ola Electric, for instance, they are talking about every second a vehicle goes out of their production line. So that is the takt time in which they are speaking. By doing so, in the next 2 to 3 years, this sort of creates momentum, and the suppliers will be able to learn from these high volume, and there will be a lot of value engineering and simultaneous engineering activities that we will be driving, and there will be more scope for innovation. And this will give highway for passenger vehicles and commercial vehicles to catch up.
So on top of my mind, when you talk about this, I think there are two big challenges that one needs to think of. One would be the technology aspect, and the other would be the logistics. So I would like to first start off with the technology aspects of it. So when it comes to India, do you think we're equipped? What are we doing about it?
So let's say if you look at if you look at the entire electric vehicle value chain, so you have the lithium-ion refineries that are necessary for you to have the raw materials ready. Then comes the cell manufacturing. So you need to have those lithium-ion cells, which are the core of the electric vehicle industry. And then several set of cells makes the battery and the battery pack. So that is another leg in this value chain. And ultimately the vehicles. So in the entire value chain, so you are looking at a lot of technology that gets, for instance, right from extracting the lithium ion to its refinement, or whether to make, let's say, green cells. That is also largely important. And then the technology associated with, for instance, battery pack, BMS and things like that, and ultimately integrating it into a vehicle.
Now, let's come to the logistics part of it. Now, this is a huge plan by 2030 to have so many electric vehicles out on the road. Now, considering we're going to have a massive number of them, you're also going to be needing charging stations, repair, maintenance, and other kind of support, right? So what is the plan? How are we going to do that? And how are we going to lead the way for that?
In terms of, Jennifer, in terms of consumer adoption to electric vehicle, this is the single biggest challenge that the EV industry has, when it comes to charging infrastructure. So let me give you a personal example. In 1998, my father bought a Maruti Omni. Back then, we were in Mysore. So the salesman from this Maruti dealership, he was a kick-ass salesman. He said, we have a new product which is fitted with a catalytic converter, and you're going with an unleaded petrol. And my father, being an engineer himself, he was blown away with this and the little environmental impact that he wanted to create. So he bought it. Little did we realize that when we took it back to Mysore, there was only one petrol bunk and one pump which could feed those unleaded petrols. So I still remember there were days when we used to, the bunk used to run out of the stock with these unleaded petrols, and for months it was not available. So we used to store, this 35-liter tanks. We used to have fuel refilled and keep it back in the garage. I wouldn't recommend that though now, but that was the scenario. Now, if you apply that in a bigger scale here, until and unless you and me see a charger in the public places, we will not buy the electric vehicles. So this is purely from a customer point of view, right? So no matter how much amount of range the product comes with, you still have something back of your mind that I may run out of battery and I'll have to recharge it. So this is the single biggest challenge in terms of adoption. There are various efforts that has been taken to amplify this. However, we still have a long way to get there.
So about repair and maintenance, how are we doing that?
Let's say, Jennifer, I think with electric vehicles, from a purely service cost point of view, this is my personal view. I think it would be 1/3 the service cost of when you compare it with ICE, because I think we have fewer moving parts in the electric vehicles. The complexity is slightly less in terms of moving parts and stuff like that. So you will still have to. Electric vehicles or fuel cells. These are not zero maintenance vehicles. So you still have to have maintenance. So probably you will have to, let's say, replace your air filters, change the tires, and probably refuel your coolants and things like that. So there is maintenance associated with that. But I think, what is more important here is to look into, is there a way we probably revolutionize this servicing space as well when it comes to automobile. Just to put some numbers, I was doing research myself, and I found out that there is around 2 million, that is 20 lakh, trained mechanics who are in this unorganized, fragmented space. So, for instance, you might see a mechanic who is right opposite to your house, who is equally good, if not more, than a Toyota technician, right? So if you give him your vehicle, he would be able to do that as well. So 2 million is pretty huge, 20 lakh workforce. So imagine if you are able to put them under a platform, bring them together, and then utilize their expertise and skills to service this entire fleet of electric vehicles that we are going to have. I think that
would be a massive turnover.
Yeah, yeah. There should be a startup around this.
Definitely. Okay, now let's talk a little bit about fuel cells. 10 to 15 years ago, if somebody had to tell fuel cells was going to make a big impact, that was a question mark. But now I think people are taking that seriously. So where are we going towards, things when it comes to fuel cells, and how is the impact on it for the EV part of it?
So I think the technology is still in the nascent stage, so it has to evolve. I mean, there is a fundamental difference in how people look at fuel cells. To me personally, how I look at it is that fuel cells are not an alternative to battery electric vehicles. Fuel cells are an extension to BEVs, whereas fuel cells could be an alternative to ICE, the IC engines. So this is a fundamental approach, right? So in order to get things right, I think you need to be very clear with the vision in which you're driving. So from that aspect, purely from an upfront cost with the technology and things like that, it has far more higher upfront cost. So we are still figuring out how we have to localize and make electric BEVs, viable for customer. So I think we are quite far with fuel cells. Now, if you look at it from an application point of view, so will you need a fuel cell vehicle for 2-wheelers and 3-wheelers? Definitely not. Will you need fuel cells for passenger vehicles? Maybe yes, could be viable. But what are all the areas where fuel cell could be a major application? So fuel cells could be a major application in long-haul trucking, right? So for example, you are driving from here to Mumbai. So all you have is a highway, and then you have to drive, probably refuel at some station. So long-haul trucking could be feasible for fuel cells, but I think you have to largely look at it from a segment-wise, and you have to look at it from an application-wise, rather than this one-size-fits-all.
So can you also tell us a little bit about the safety aspects of the hydrogen cells?
We are fascinated by the fact that the exhaust of the fuel cell is water, right? Now imagine a scale where every vehicle on Earth is a fuel cell vehicle, right? So the trucks, the buses, the cars, and things like that. The amount of water that is drained out of those vehicles, I'm exaggerating a bit, we are literally creating a swimming pool, right, on the roads. Is it good to drain water on the roads, or is there a mechanism that we have to figure out where we have to store it in a tank and then drain it at some point? If so, we are adding weight, and then there are safety aspects associated with that. So you are complicating, yeah. and the more you're complicating the things, so the more is a risk on the safety. So of course we are trying to figure out solutions to work around this, and there will be solutions, and I'm very positive about it. But I'm trying to give you a reality that where we are. So it looks fancy when you say, okay, we have to have fuel cells, we have to have BEVs. It is good, and I think we need to move in that direction. But today where we are, we have let's say limitations in technology. The technology has to evolve, and then there are a lot of associated infrastructures that needs to evolve as well to get there. So it's slightly further behind BEV adoption, I would say.
So now I want to talk about something that not a lot of people are discussing at the moment. That would be the talent gap in an industry that is ever evolving, right? There's a lot of updates, a lot of things that are still in the works, right? So to be honest, we all know that the Indian education system is not in pace at the moment with what's happening in the industry. So how difficult do you see, the right talent to be hired or the right talent fitting into the industry? How difficult is it?
Right. I'm of a person who believes that higher the exposure, the greater is the chances of success, right? So it is applicable for every aspect of life. So if you look at the tier one engineering colleges, like for instance IITs and NITs, they pretty much are much better in terms of giving exposure to their students. However, I think the tier 2 and tier 3 colleges and universities have to put in a lot more effort in terms of getting closer to the industrial needs. Now, if you look at largely the automobile industry, so you have, I think, roughly 35 million jobs today. Around 20% of these are from the tier 1 colleges, so IITs and NITs. Whereas predominantly the 80% of this comes from tier 2 and tier 3 colleges. So there has been always a huge investment that a company makes on he or she who joins just out of college. I mean, even today, a large part of automotive industry works on waterfall methodologies, which means that you were hired because you had the ability to get things done, you had the ability to keep things together, and then you had possibly the aptitude that is required to get in and do the job. So this is how a person was evaluated pretty much to be onboarded onto a company, whether it is fresher or experienced. So it's a different scale. Whereas if you look at today, some of the organizations are already leading in terms of transitioning to agile methodologies. It's funny sometimes in automotive industry, when you say agile, they think implementing Jira tool is agile, but it's far beyond that. There is a fundamental shift in the way we think about product with agile methodologies. So today, I think in order for you to be attractive to employers, the best is to hone your skills on design thinking, critical thinking, and system thinking. So the day you get a grip on these three things, you're far more employable. Because today, largely, the organization are driven productized, and it's more than the repetitive task that people used to do before. So you're starting to see a large OEMs possibly giving you case studies, asking you to present on, for instance, how would this product look like, or how would you optimize, how would you solve the problem. So problem solving and these kind of things are far more critical. Added to that, with this EV coming into picture and agile methodologies into picture, certain amount of specialization is required. So the specialization drives the salaries.
Much more refined and niche,
Absolutely.
the options. Yeah. So I was interested even in the recruitment part of it. So this is a growing industry. So currently, you said there's a particular amount of jobs available in the market. How much do you see that increasing in the next 5 years?
Well, absolutely. I think in the by 2030 there is this prediction that I think the automotive sector or the EV sector at large is going to create 100 million jobs. So that's a massive amount of. That's more like 3 times more than what it is today. So pretty much all smart people have their job in some of the coolest companies. So.
So in about 9 years, you're saying that's going to be a massive boom of jobs.
Yeah. I mean,
But currently, also, I think there is quite a bit of growth. Literally every other year, I think there's something or the other that's been coming up, basically. So there is quite a bit of growth.
Absolutely. When I say 100 million, it starts from now until 10 years.
Yes.
So you're already starting to see the traction with Ola Electric coming into building their gigafactory, or having their technology center in Bangalore. So they're massively recruiting. So this is just a start. Then you have the biggest two-wheeler maker in the world is Hero Motors. right? So they have been experimenting on their electric vehicles, but however, they're an investor in Ather as well. However, you can expect from in the days to come. So Hero might have their gigafactory and technology centers associated with electric vehicles. There could be TVS is coming up with their roadmap with electric vehicles. Then you have Bajaj planning to also create a different brand for electric vehicles.
This is all just in the two-wheeler.
This is just in the two-wheeler. And think of Mahindra Electric, Tata's wants to go for fully electric. Then you have the multinationals, like for instance Volvo Group. You have Volkswagen, Toyota, who have been in the Hyundai. So we have been in the business for nearly 20-25 years. So there is a massive opportunity, and with Tesla coming to India, I think this entire space will shake up.
Right.
So, yeah, I think it's an exciting time to be engineer.
So, what do you think a tech platform should be doing? For example, when you take SkillLink, right? We build our own curriculum with industry experts. We see that we give them job relevant skills. We have instructor-led sessions also from industry experts. So what more can be done in order to address this gap, at least in the EdTech platform?
Right. The broader question is, how would you upskill and reskill the current employees that you have in the organization? That is the first part of it. And the second one is that when you hire people outside the organization, whether it is freshers or experienced, so how would you ensure that they have the necessary skills preloaded into them? So this is where perhaps EdTech platforms like SkillLink will have a huge role to play. For instance, for upskilling and reskilling, every company spends enormous amount of time, energy, effort, and money to sort of support the employees to take on their next big role that they want to. And one of the necessary ingredients is to be equipped with the necessary domain expertise that is required to get onto that role. I think this is where we have a gap today. So, for instance, if you look at the entire EV industry, in the entire value chain, there are lots of new technologies that we have a possibility to apply, where we will have to develop these skills to the potential employees and also to our current workforce. So there is possibility to sort of have the industry leaders or the technology experts or the people who have worked hands-on probably utilize their expertise to transfer those knowledge to the entire workforce. So in some way, if you look at automotive industry have been pretty good in terms of job rotations. So we have 100,000, 200,000 employees globally, and then you get to actually move around the organization, take different roles. So that has always been the case, and I think it will continue to be. Then there is some amount of this accounts to large part of the organization, and then there is a next layer, which is a few people. By the time we are going to go 100% electric, they are going to retire. So there are going to be that set of people who will be moving out of the organization and industry, where you will recruit people fresh out of fresh graduates out of schools, or people who are already industry ready from an EV point of view. And then there is only some portion of the jobs that gets redundant, and that is where you have to actually put focus to sort of upskill and reskill them so that they are far more, they have a better possibility to be employed. So that is the area in which we need to focus. So if you look at any OEMs, largely, previously technical expertise used to be shared with suppliers and the OEMs. So the kind of knowledge stack that you used to have were distributed with various levels. Like you used to have suppliers, then you have the OEM on top of it. So it was kind of distributed. Today we are talking about vertical integration in more or less every areas, which means that we will also have to look into vertical integration on the talent side as well. So we have already started to see that the electric vehicle companies starting to hire people with specialities in terms of their expertise in battery management, their core expertise in batteries. So they are directly employing people with this background and expertise and skills. So it's important for us to build that within the organization as well, and provide opportunity for people who are already employed, because you have such a loyal workforce who have worked with you for 20 years, 30 years. And they have been with you with all the ups and downs, and it's important for every organization to give them a chance to actually transition their careers. And I think every employer is very serious about this, and that is where the EdTech platforms could be a bridge, if I say so.
So what would your advice be to students who are currently pursuing mechanical engineering and automotive engineering as a course? How do you think they should prepare for this to get into the EV sector?
First of all, my message to them is they are on the right track. So it's good to be in this space. I think this is a very exciting space. So my advice, or I would say suggestion, is that let's say, if you look at, we are in the middle of fourth industrial revolution, right? So this is the very beginning of digital transformation, fourth industrial revolution, and there is a lot of initiatives that are ongoing globally. So with that said, what is driving this fourth industrial revolution is in terms of those disruptive technologies. If I talk about, there are pretty much 9 disruptive technologies that are actually impacting or disrupting the way we are doing things today. So to name a few, those technologies are, for instance, 5G, cloud computing, artificial intelligence and machine learning. You have digital twin, additive manufacturing. So there's some more as well. So for instance, if these are technologies which are going to create very high paying jobs in the near future. So these are the specializations that I talked about, right? So every automotive industry is putting enormous amount of effort in terms of digitalization. So adapting AI, ML data platforms to sort of optimize their processes and things like that. So you have a wide variety of opportunities, and then what is important is to have one and kind of master that. And that gives you far more, that will make you attractive to employers. So that's pretty much my suggestion and advice to.
Okay. So when you talk about electric vehicles, the first thing you think is a mechanical engineer would get into this field, automotive engineer would get into this field, but you were also talking about AI, and it's still a particular sector that's still growing. What would you think are the other engineering, I would say, pursuing degrees that could look into this, for example, for AI?
Oh yeah, I mean, if you look at if you look at the traditional automobile, it was more of a car. Now you're talking about it as a device.
Right.
So mostly we are hiring computer science engineers and electronics engineers into this space, because we are talking about different things here. So if you look at the automotive industry, so there are the research and development, which is in some way a large employer from a department perspective. So there you have possibility to explore the technology side of it. Then you have manufacturing engineering, for instance. So those are process design and process development, manufacturing engineering. These are equally good spaces. For instance, you have a lot of application of AI and ML already now in this space than actually
Right.
on the product development part of it. So this is one such area. Then you talk about the purchasing and sourcing departments in any of the OEMs, for instance. It's a huge organization where we talk about a lot of P&L, for instance. Blockchain plays a phenomenal role in this purchasing department. I mean, when we write contracts to suppliers, there is a whole lot of new opportunities. So it's not just mechanical and automotive engineers that would account to, I don't know, 40 to 50%. I think 40%, but the 60% is largely computer science, electronics, these kind of things. So there are areas where, for instance, power electronics. We talked about battery management systems. So these are purely software stack that you're going to build on top of your battery layers to manage and optimize that. So these are the other areas, for
Multiple
instance.
areas in a way
Yeah,
they can.
yeah.
Perfect. So how do you think the current engineers in the automotive industry can, kind of move on to EV and adapt?
So let's say, for instance, I was speaking to a friend of mine who is a surgeon and happens to be a venture capitalist as well. So a kind of unique combination. The guy said, so much of, a large part of the money within the healthcare space is going for cancer research or heart or diabetic related research and stuff. So, if you look that, if you kind of apply that analogy here, the IC engines are going to stay for the next couple of years at least. But will there be any investment or funding to do further development in terms of technology and things like that? Maybe not. So I think it will slowly scale down in terms of funding and investment, because everyone is focusing on channelizing their capital to electric vehicles, fuel cells, and the future technology. So being an engineer, it is important for you to work on some of the exciting stuff. So at least I, as a person, feels that I want to be part of some of the innovative programs that the organization runs. And if you are one such person, it is important for you to be part of the EV. You will still keep your job, perhaps, if you are in the ICE space, and probably you would enjoy that as well. But I think if you want to have far more meaningful impact, I think it's important for you to make a transition to EV. There are several ways to make a transition. First is that if and when within your organization you have a possibility to be part of, let's say, some of the investigations or running the pre-study or these kind of things. So these kind of experience will create some sort of opportunities for you to sort of transition yourself to EV. So that is one step within the companies. I mean, the second one is that I think every organization runs a lot of upskilling and reskilling. We talked about it earlier as well, what edtechs will play a role going forward. So I think you can take such opportunities to transition yourself. And one thing that is not very common in India, but I would like to personally see this happening, is internships at different levels. So if you look at US or some of the developed countries, people take a step back when they are making a career transition. They would like to go as interns, even if they are in middle management or senior management positions. So they would like to work with, for instance, as an intern with a founder, or let's say a middle management role, internship in Tesla, for instance, or a graduate entry level. So there are, I think it's important that possibly if we have such a possibility going forward, companies like Ola Electric, Ather, or any of the multinationals, like whether it is Volvo or Toyota, if we are able to create such opportunities for people to join the organization, do their internships, they get to learn, and we get to benefit from their experiences as well. and that will help building this ecosystem. So I think we have to look at it largely from that aspect.
So now that we're at the end of this discussion, I also wanted to talk about your entrepreneurship journey as well. So you've actually built an app, right, or a product, I guess. It's called Dr. Bean. Can you just tell us a little bit about that journey and why all of a sudden there was an interest in this and what it is and how did all that begin?
Right. I think back then it was, I think, in 2014 or 2015. 2015, yeah. I was in France and I had to get hospitalized. And then it was funny. I can't speak French, and none of my colleagues could speak French. And at that point of time, we were on a business trip, and then I was hospitalized, and then there were a lot of things that were happening around me. And then one thing I got to see was there were a lot of use of digital technology in that particular French hospital. Then I came back to India, and then I went to one of the super specialty hospitals that we have in Bangalore, and incidentally, the total experience was different. So I was waiting in a long queue, and then to meet the doctor, and then to get it examined, it was a hassle. So then I happened to discuss it with my fellow colleague and a friend of mine, and then we said, okay, why don't we do something about this? That's how we conceptualized Dr. Bean. Initially, it was called Jiva. We were among the first few online pharmacies in India. We were pretty good, actually. We were doing 30-minute delivery in Bangalore. So we were a hyperlocal delivery model. So we partnered with a lot of pharmacies around Bangalore, Delhi, and Mumbai. We scaled it to Delhi and Mumbai as well. And then we were starting to deliver medicines online. So a customer can take a picture of the prescription and send it to us, and then we deliver the medicine within 30 minutes. So we were the one who first brought those things. Then while we were scaling it up, we had a lot of regulatory challenges and things like that. And at that time, it was massive. Some of the companies were wiped out at that time. So we pivoted it into a prepaid healthcare model, where we were partnering with companies like Infosys, Mindtree, and to offer, let's say, cashless OPD services to their employees and family. Cashless OPD, you mean, if you look at today, insurance is that you have to be hospitalized for 24 hours to claim those insurance. Whereas going to doctor consultation, getting medicines or diagnostic services are not covered in that. So our model was to cover those aspects so it was a cashless OPD, prepaid healthcare. We were doing pretty good, and then there were some macro factors that were very challenging. So we dismantled the organization. A part of it is still running. It's incubated in IIM Bangalore in Nalsar. One of my co-founders is still running the show. So this is a bit of a entrepreneurial journey that I had.
Lovely. So, in the last 12 years of your journey, when it comes to your career, you've worn multiple hats, not just in EV, but you've also had, completely different side of things going into tech. So, before you finish this complete conversation and we wrap up today's session, I just want to know if you would like to say a few words to the young engineers and students watching this video right now.
Sure. I think scoring marks and being part of university education is really important. It is good, but I think you need to think beyond that. So I think as students, you have nothing to lose, right? So you have to take big bets, big bold bets. Engage yourself, be part of some of the initiatives with edtechs. Get yourself upskill yourself, understand how the business runs, probably start a startup, try to understand how the business functions, or get into the innovation side of it. I mean, do research. Probably this is a golden opportunity. So you get to have your own patents. So there is a lot of things that you can do around. And then the last part is in order to be employed, and that is always a big opportunity. So find the right employer whose values and the culture of the company has far more social impact than just joining an organization which has merely any value associated. So I think these are some of the things that you have to, as a student, make choices, which is difficult. It is not it's not easy, but I think you have a lot of people around you who can mentor you and take you towards that. So explore those opportunities.
So thank you so much for joining us today on this particular session in Engineering Leaders, Mr. Anup, and we wish you all the best for all of your future endeavors.
Thank you, Jennifer. Thank you for
so
having
much.
me.
Lovely seeing you.